Thank you very much. Welcome, everybody. My name is Mark Vince, and in this session, we are going to talk about how to implement gRPC services in .NET. And before we start, I just want to say thank you to Mindwork for organizing this meetup and inviting me. I'm really excited to be here. And also thanks to everyone for joining. I hope it's going to be locally in an application when we are doing programming. For example, let's say we are programming in an object-oriented language, then we have an object. In this example, it's an object of the type user client, and we have another object called user service. And if it's a local method call, then it is happening in one single machine in one application process. What an RPC is about, a remote procedure call, is that we would like to do a similar method call, just that the two objects from which we are calling the method and on the object on which we are calling the method, they live either on the same machine but in different processes, or they live in different machines. And if they live in different machines, then that method call needs to travel through the network. And the way that happens is that the method call needs to be serialized in some way and transferred over the network. And then on the consumer side, it needs to be deserialized, processed, and then the response needs to go back to the caller. And when we are talking about an RPC, then typically the programming model of this is very similar to doing a local method call. So the developer who is doing this might not even notice in the application code that the other object is living on a machine, on a different machine, and that the call is going through the network. So this is kind of when we are using this technology for example, for service-to-service communication, it is different from using a REST API or a similar technology, because in case of REST, we are quite aware of the fact that we are sending an HTTP request and we are utilizing the capabilities of HTTP specifically. On the other hand, when we are doing RPC, then that detail is typically hidden from us. And there are a lot of different RPC technologies in the industry. Some of them are technology specific, some of them are not. Some that you might have heard about, for example, Corba, I think is an enterprise technology for C++. Then there is RMI, which is used in Java. In .NET, we had remoting in earlier versions, which was for the same purpose. I think it was then pretty much superseded by WCF, which we can also kind of think of as an RPC technology. The one that we are going to talk about today is gRPC. So gRPC is a high-performance RPC framework, and it is agnostic to the technology stack. So any programming language and technology stack can have an implementation. And because it is very widely adopted in the industry, I think every popular technology stack today has a gRPC implementation, and it is very suitable for service-to-service communication in distributed systems, and it can be very useful even if the services are using different technology stacks. So you can implement a gRPC service in .NET, and then you can call it from Java or Python or Node or any other popular technology. gRPC heavily builds on top of a technology called protocol buffers, which we are going to see in a minute. And it is using protocol buffers or Protobuf for two purposes. It is used for the serialization during the data transfer. And also the definition language of protocol buffers is used or utilized to create the service definitions. And because in the gRPC services, both the service endpoints and the data models have a strict specification with protocol buffers definition files. Client libraries and data models can be created with code generation. So with gRPC, we are not handwriting the clients and the API requests that we are sending, which is something that we often do in case of REST, but the clients are always generated for us. And gRPC heavily builds on top of the capabilities of HTTP2. So by default, it can only work with HTTP2. And one thing that is achieved with that is that besides supporting a simple request response communication pattern, it also supports bidirectional streaming. And this technology originated at Google, but now it is open source and it is widely adopted in the industry. And the main benefits it provides compared to something like REST is that it can have a better performance. One reason can be that HTTP2 itself provides performance benefits, but also the binary protocol buffers data format can be smaller and faster to serialize. The strict contract definitions can be very useful for code generation. And the last thing is that it also supports a streaming communication model besides just request response. And before we look at gRPC, let's take a look at protocol buffers, or also called Protobuf. So Protobuf is a language-neutral binary serialization technology. And the way that it works is that in the Protobuf schema definition language, you need to define your data model. And you can see an example of that on the left. So this is a very simple model definition of one single person type, which has 3 fields. And once you have this schema definition, then you can use the Protobuf tooling to generate data models for you in the technology stack that you are using. And all popular technology stack has tooling for Protobuf. And once you have that, then you can see the example on the right, how you would use it in C#. So when you do the code generation, it will generate a .NET person type for you based on that model. And then you can instantiate that model, you can serialize that into a binary, and then you can parse that binary back into a .NET object. So let's see what this looks like in practice. I have a .NET solution prepared here, and it has a Protobuf serialization project. This is a simple console application that I'm going to use to show how Protobuf can be used in .NET. In this project, I have a Protobuf demo file, and you see that this is the same model definition that we had on the slide. So we have a person type, and it has 3 fields. And one thing that's important is that in the project file, I have added a reference to the gRPC tools package. And this package is important because this provides all of the tooling capabilities to do code generation based on the model. And the other important thing is that this protobuf demo.proto file, this is included in the project with this special protobuf tag or element. And this is what tells the tooling that we want to get code generation for that model. Now, this is something that you can type manually in your project file, or if you're using Visual Studio, you can get this by selecting the properties of the file and change the build action to protobuf compiler. So this is what is going to give you the correct setup in the project file. And once we have this, we can see how we can use this for serialization. So in the program.cs, I'm creating an instance of this person. And if I check the definition of this type, you see that this is coming from the generated code. And this is, of course, it's difficult to read, but typically you don't have to look at this. When you are actually using this in your application, the type looks like an ordinary C# POCO data model, so it's convenient to use. And then I can serialize this into a byte array binary with this 2-byte array extension method, and then I can parse the binary back into an object with another method which is provided by the tooling. So these methods, for example, the 2-byte array um, extension method and this parser and parse from methods, these are provided by the Google Protobuf NuGet package. So that's the reason why we have this other NuGet reference here. And what I'm doing here is I'm just printing out the two objects to the screen. So the original one and the one that we received when we deserialized the binary back into an object, just to see that we still have the same data in the object. So let's run this and see if it works. And you see that it worked. So it printed the same information twice. And here, for the sake of the example, I'm serializing into a byte array, but there are a bunch of other overloads of these methods. So you can serialize into a stream or a span. So there are various ways to use this. So I think this example shows that the Protobuf tooling in .NET and Visual Studio is really easy to use and has kind of a low barrier of entry. So if you want to get started with protocol buffers, it is really easy to get started with it. And protocol buffers can be very useful without gRPC as well. So if you want to do network communication and you need to send binary payloads, especially if you want to interoperate between different technical stacks, then Protobuf can be very useful for that. Or if you want to save something in a database as a binary blob, Protobuf can be used for that as well. So it can be utilized for a lot of things outside of the scope of gRPC too. After looking at protocol buffers, let's see how we can implement gRPC services. So when gRPC was created, they needed a definition language to specify the services and the service endpoints. And because gRPC was building on top of protocol buffers for the data format and the data serialization, they decided that they would not create a new separate definition language for the gRPC services, but rather they would implement that as an extension of the Protobuf definition language. So in this example, this service element that you see on the top, this defines a gRPC service. This is called user service, and it has two methods, create user and get user. And then what you see in the bottom, these are the various data models which are used by these service endpoints. For example, the first endpoint or first RPC, the create user, it has a create user request input, which contains a username and an email, and it returns a create user response, which has a user ID. So the bottom of this definition file with the message elements, this is just standard protocol buffers. And then this service element is the gRPC extension on top of it. So in theory, I could take this protobuf file and use these models just with the protobuf tooling, not with gRPC, and create these objects and serialize and deserialize them. And the protobuf tooling would just ignore the service part because that is gRPC specific. I don't know how useful that would be in practice, but this is how Protobuf and gRPC comes together. So the gRPC part in the service definition is kind of an extension on the definition language. And when we are getting familiar with gRPC, I think especially for developers who are already familiar with REST, it can be very useful to do a comparison of how it compares to REST and what the main differences are. So let's take a look at these. The data format in case of REST APIs is typically JSON, although it can be something else as well. It could be XML or it could even be binary. You could even have REST services with protobuf binaries, although I don't know how common that is, but it would be possible. But typically it is JSON. In gRPC, by default, it is a protobuf binary. I say by default because there are other alternative implementations of gRPC which are using other serialization technologies, but the default one, which is kind of officially supported and supported by most of the implementations, is protocol buffers. The communication protocol in case of REST is HTTP, and I did not specify a version here because REST can work on either HTTP 1 or HTTP 2, but the communication pattern is typically simple request response. So REST APIs don't utilize HTTP 2 specific capabilities. So if the client and the server both supports HTTP 2, then maybe HTTP 2 will be used, but the messages that we are sending on it are just ordinary HTTP 1 messages, essentially. In contrast, gRPC heavily builds on top of HTTP 2, so it can only work with HTTP 2. The API contract style is pretty different in the two technologies. In case of REST, there are a specific set of guidelines around how to structure an API, and that builds quite heavily on top of HTTP concepts. So things like the various HTTP verbs, headers, status codes, they all have meaningful roles and specific meanings in REST APIs. On the other hand, in case of gRPC, we are not really utilizing HTTP concepts, but what we are doing is much more similar to ordinary programming, where we are creating a class and creating methods. So in gRPC, we are creating services, and in services, we are creating endpoints. And how we are structuring those, or what kind of groupings or hierarchy we use, is pretty much up to us, and there is no specific set of guidelines. So from that sense, it is more similar to ordinary object-oriented programming or design. The contract specification in case of REST is typically we don't have a strict specification for the services, but usually we can generate a Swagger or Open API documentation, and then that can be used for certain automation or code generation. On the other hand, with gRPC, we always have a strict specification by default in the protocol buffers definition language, and then we can use that for code generation. And the communication pattern with REST is typically simple request response. And gRPC supports 4 different communication patterns built in. It has unary, which is request response, and then it has 3 different streaming variants. It has client streaming, when the client is sending messages on one connection, server streaming, which is in the other direction, and it has bidirectional streaming, in which both the client and the server can keep sending messages to each other. So that can be useful for a scenario like a chat application, when you can send messages on one open connection on both direction. And now let's take a look at how we can start using gRPC in .NET. And I've put this summary slide here, which shows the various NuGet packages which you can use for gRPC. I think this is kind of useful for a reference because it can be a bit confusing at times what you are supposed to use. So grpc.core is the old gRPC implementation in .NET, which was built on top of the native C library as kind of a wrapper. Now, this library is considered obsolete at the moment, so we should not use it for new development. But if you see it in some old service, then you will know what this is about. The second one is Protobuf.net. This is an interesting one. So this is an alternative Protobuf implementation for .NET, but it is not using the Protobuf schema definition language, but instead it is using C# attributes to achieve the same thing. And then I think how they describe it in the official documentation is that it just happens to generate Protobuf binaries in the end. The main purpose of using Git is if you have a purely .NET technical stack, so every service is in .NET, and all of them are using Protobuf.net with these attributes, then it can be useful for not having to write Protobuf definition files. But I don't think that it works together with gRPC, and it doesn't work with kind of the official up-to-date gRPC implementation that we have today. But I think it's good to know what it is about if you happen to see it somewhere. And then the last four packages on this slide, these are the current up-to-date packages that you can use for gRPC. So gRPC tools and gRPC Protobuf, we've seen these in the example earlier when we were doing the serialization. So gRPC tools gives you the tooling for the proto file references and code generation. Google Protobuf gives you the message serialization and also a bunch of simple base types that are needed by the generated code. And then gRPC.NET Client is for creating gRPC API clients, and gRPC ASP.NET Core is for hosting gRPC services in ASP.NET. So let's see now what we have to do to actually create a gRPC service in ASP.NET. This is an example service contract, a very, very simple one. And you might have seen this in the past because I think this is what is in the official gRPC, like getting started tutorial. Also, if you run the .NET new gRPC scaffolder, then this is the service that you will get generated. So this simple greeter service is typically used as an example. So it has one endpoint called say hello. It takes a hello request, which has a name field, and the response is a hello reply, which has a message field. If we want to implement this in ASP.NET as a service, we have to add this proto file to the project. And then what the tooling is going to give to us with the code generation is that it is going to create this greeter.greeter base class. And we have to inherit from this class and create a custom service. And in that service, we can override a method for every RPC that we had defined in the contract. So in this case, we had only one RPC, the say hello. So we can override it in our class as the say hello method. And inside here, we can implement the business logic, whatever we want to do. And also we can use here dependency injection the same way as we are used to in MVC controllers or in any other types in ASP.NET. So we can, if we are experienced already with ASP.NET MVC, then these service types are very similar to MVC controllers. And these RPC methods, these are similar to action methods on the controller. And then in order to register this in ASP.NET, first we have to call add gRPC. This adds the necessary services to dependency injection. And I missed the semicolon here. I'm realizing it now. And you also have to call this map gRPC service method, which actually registers this service into the ASP.NET pipeline so that it will host this service. So let's see what this looks like in practice. I have this prepared in the other gRPC demo web project. So we have here the proto file, and this is the same proto file that you've seen on the slide. We have one service with one say hello RPC. And then once this is added to the project, the base class for the service is going to be generated for us. So we have the greeter service implemented, and you see that this greeter base, this is coming from the generated code. And then here we can implement whatever business logic we want to run. What we are doing in this simple example is that in the input, we receive the name, so that is request.name. And what we are replying with is hello and the name. And in the program.cs, I had the necessary registrations added. So I'm calling add gRPC, which adds the necessary dependencies. And I'm calling map gRPC to start hosting the service. And This project was generated with the official .NET new gRPC scaffolder. And one interesting thing which is added by default is this line. So this registers a route, the root of the API, and it is going to reply with this message, which says that communication with the server is only possible with a gRPC client. And I think this was added so that if someone just opens this web services root URL in the browser, then they will get this message which will tell them that you cannot really just open this service in the browser. You need to use a gRPC client to actually access it. Let's now start this project and see how it works. You see that it has started already, and it started listening on two addresses, on HTTPS and on HTTP on different ports. That is just because this is how the launch settings in the project are configured. So this is where it is configured to listen to those two addresses. I'm going to use the HTTPS variant, and this is going to be relevant a bit later. So let's try to open it in the browser. If we open it here, you see that we are receiving this message that was configured for us in the startup of the application. And this brings us to a drawback or a difficulty of gRPC, which is if we are using REST APIs, it can be very convenient that a REST API endpoint, at least one that needs a GET request, is very easy to test in the browser because I can just navigate to it, open it in the browser, see the JSON response, and I can test it that way. And that is not possible with gRPC. One reason is that with gRPC, the data format is always a protobuf binary. So there is no way to handwrite a binary input. The other reason is that gRPC doesn't just use simple GET requests, but it heavily builds on top of HTTP2 capabilities. So there is no way to exercise a gRPC service from the browser in this way. When we are doing testing, there are a bunch of different tools that we can use to exercise a gRPC service. One that you might have used before, or maybe a lot of people are still using it, is BloomRPC, which was, I think, a pretty popular tool, but now it's deprecated. I think Postman also introduced gRPC support, I think 2 years ago. Probably a lot of people are using it because Postman is very popular. There are also CLI tools. So if someone likes curl, for example, then there is a gRPC tool for the CLI as well, or for the terminal. The tool that I like to use, and I recommend it to everyone, is called Crea. The thing I like about the Crea tool is that when you create a project for testing a gRPC service, it generates a project file, which is then very easy to also commit into source control and then share it with your team. And then you can work on the same like test suite or test requests. But if someone else prefers other tools, I'm sure that the other ones work well as well. So in this Crea client, I have created a project already, and I imported from the same folder, I've imported the same proto file. And based on this, Crea already generated for us this service overview. And of course, in a real application, it would be much more complicated. So there will be a lot more services and RPCs. But in this example, we just have one single service with one RPC. And if I want to call this, I can edit the input here. So our input type only had one field, the name. So this is what I have to populate. I've put here Jane. And if we look at the settings, I can also verify, yes, I have set this up to connect to the HTTPS endpoint. And just to see that it is getting called, let me put a breakpoint here in the service and call the endpoint. And you see that the breakpoint is hit. And in our request object, we can see that indeed the name field is populated as Jane, how we set it in the client. And another thing that you might see is that there is this server call context argument, which you get by default in every generated RPC method. And if we look at what this contains, it is pretty similar to an HTTP context for ordinary HTTP requests. So it contains a bunch of contextual information about the request. One interesting thing that you can see here is the route. So gRPC also uses actual routes under the hood, but this is something that you don't have to be familiar with because you will never manually implement actually sending requests to these routes. This is something that the generated code, or in this case, the CREA client takes care of, and it's part of the gRPC specification that these are the routes the server has to work on, and then the server and the client both have to implement it in a correct way. But as a developer, you don't have to be familiar with these, but you can always take a look if you're curious. And if I let this go, then in the client, you will see the response, which the way we implemented it is we take the name and we've added hello to it. So this is a basic example of how you can implement a gRPC service in ASP.NET. And of course, in a real world application, the service itself would be more complicated. Like probably you would have more services, more endpoints, and of course they would implement real business logic. But just in terms of creating the gRPC service, this approach and this level of like setup and configuration is enough for a real life application as well. So I think this shows that the gRPC tooling, similarly to the Protobuf tooling, is pretty easy to use, and you don't have too much setup to get started with it. And the next thing I want to show is that in a real application, of course, the way you would call a gRPC service would not be from a tool like this. This is just for testing. What you would want to do is implement an actual client in another service probably. So I have an example for that as well. In this solution, I have another project, the gRPC demo.client. And in this project, I have the same proto file. And the gRPC tooling generates from this proto file not just the base classes that you need to use for implementing the server, but it also generates client types that you can use to call the service. And that is what I'm doing here in the program file. So this greeter.greeter client, this gets generated for you based on the contract. And I'm creating an instance of it. I'm passing in the address. And I would like to use the HTTPS variant. So I'm going to change this to the HTTPS URL. And I call our method, the say hello async. I pass in an input. In this case, I'm passing in John, and I print the output. So let's see if this works. I will start the web server in the background. And it is running. So now when I run the client, I'm trying to set this as a startup project, but for some reason I can, oh, sorry, I had still the debugger running. Let me start it again. Okay, so now the server is running in the background. I will set the client project as the startup project, and I will start it up. And what I would expect to see, because we passed in John, what we should see in the console is hello, John, as the response. And you see that it indeed is working. And then, of course, if you are in an organization where you use multiple different technical stacks, then you could take the same proto file and you can use it in a Python, Java, Node.js, or any other technology. And in those technologies as well, the code generation would provide you a similar client, and you would be able to use the service that way there as well. So after looking at this basic example of how to create a server and how to call it with a client, the next thing I would like to take a look at is interceptors, which I think is a gRPC capability that probably comes up in in a lot of real-life applications. Interceptors can be used to implement and add common cross-cutting functionality to the gRPC request pipeline. So things like logging, metric collection, model validation, authorization, things that you want to implement just once and then share it between your services or share it in the whole organization and reuse everywhere. You can use interceptors to implement these. And the server-side interceptors are very similar to the ASP.NET middlewares that we are using in MVC. And the client interceptors are similar to the request handlers that we are using with the HTTP client. But in case of gRPC, these are both called interceptors. Just one is a server interceptor and the other is a client interceptor. I think probably the most typical example is to implement logging. So this is an example of how you can implement a server interceptor which implements logging. You have to inherit from interceptor, and this is going to give you a couple of methods that you can override. And these methods are specific to the various communication patterns. So the unary request response, client streaming, server streaming, and bidirectional streaming, they all have their own method to override because you might want to handle them in a different way. And in this example, we are only handling the simple unary request response scenario. And what we are doing is we are logging a message saying that a certain method was called, and then we execute the actual method. So let's see this as well in practice. In this web project, I have prepared this interceptor. This is almost the same as what we had on the slide, but it also contains error handling. So I have a try catch here. And in case of an exception, we are also logging the error. And in order to use this interceptor, I need to register it in the configuration of the application. So in this add gRPC, I can pass in a Lambda to do further configuration. And I have to pass in this piece of configuration in order to register the interceptor. So what I'm doing is adding the logging interceptor to the list of interceptors. Let's see now how this works, and I will remove for now the breakpoint from the service just to not stop the application. So let's start it up. So the application has started, and let's now open the Crea client. And the thing that we've implemented was this processing call message. So this is what I expect to see on the console when I do the actual request. So let's send now the request. And you see that indeed we logged a message here to the console. So this interceptor capability can be used for these kinds of cross-cutting concerns. And typically what you would do is that you package it into a NuGet package, and then you can share it and use it in all of the services that want to take advantage of them. So after interceptors, I would like to move on to another topic, which I think can be a bit confusing at first. But I felt that it was important to take a look at it because this is the thing that I found the most confusing when I get it started with gRPC. And also I felt that not many of the getting started tutorials mentioned that this can be a problem. So I mentioned earlier that gRPC heavily builds on top of HTTP2, and it can only work with HTTP2. So let's now try something and see how it works. So in the launch settings of this application, we have both HTTPS and unencrypted HTTP configured. Let's see what happens if I try to use the unencrypted HTTP URL, because up until now, I was using HTTPS. So I start up the application. And if I go to the browser, I still have this URL open. Let me call it again, and you see that I still got this message that was registered in the configuration. So let's see what happens now if and HTTP is listening on port 5000. And you see that now it did not work. I got an error message which said that an HTTP1 request was attempted to be sent to a server which is only capable of serving HTTP2 requests. And this is an error message which is sent by Kestrel, the web server which is in front of ASP.NET. Before we look at why this is happening, let's take a look at whether the HTTP URL works in Crea to call the actual gRPC endpoint. So I have to go to the settings of the project, and let me change this as well to the unencrypted URL. And I have to disable the TLS validation, and let's see if it works. And you see that the gRPC request is still working. So the question is, why is this happening? Why we cannot access the root endpoint with an HTTP1 request? The reason we are getting this error message is because in the appsettings.json, there is a piece of configuration, and this is included by default by the scaffolder when you do .NET new gRPC. I don't think it is included if you do like .NET new MVC or .NET new Web API. And what this does is that it instructs Kestrel so that the web server will be forced to use HTTP2, and it is not. It is going to reject any HTTP1 request. Probably the reason why this is included in the default scaffolder is because gRPC really needs HTTP2. So from that sense, it does make sense to force it. But let's say we are in a scenario where we want to support both HTTP1 and HTTP2, which can be a genuine requirement. For example, if you want to have both MVC controllers and gRPC services in the same project. This protocols field, this is an enum, and actually it has another value, which is HTTP1 and HTTP2. So this seems promising because this is what we want. We want this application to support both protocols. And then in the browser, when we call that simple endpoint, or if that was like a REST controller endpoint, it would use HTTP1. And if we call the gRPC endpoint, it would use HTTP2. So let's see whether this works. I will start the service again. Let's go to the browser and now try this request again. And if I refresh it, you see that now this works. So the simple HTTP1 GET request was working. Let's now try the gRPC request in Crea. If I try it now, you see that now the gRPC request is not working. And what this error message says, I think it's a bit cryptic and a bit difficult to read, but essentially what it says is that the client tried to send an HTTP2 request to the server because it's gRPC, so Crea was sending HTTP2, but the server is not capable of supporting HTTP2. And there are two questions here. So one is, if we configured this configuration as HTTP1 and HTTP2, then why did Crea receive this error message from the server then that only HTTP1 can be used? And the other question is, why did this work perfectly well when we were using HTTPS? The reason for that is, if we are using unencrypted HTTP, then when the HTTP communication begins, for example, the browser sends this request to the server, the first piece of data that goes through the network as part of the HTTP communication is immediately the beginning of the HTTP request. So there is no like handshake or any other communication that would precede the HTTP request. And the HTTP1 requests and the HTTP2 requests, they have a completely different format on the wire when the actual bytes are being sent. HTTP1 is a text-based format. So what is sent over the wire is the literal characters. For example, in this case, when the browser sends a simple GET request to the endpoint, the bytes which are getting transferred over the network are going to be the GET space and then the URL, those characters in ASCII or Unicode. On the other hand, HTTP2 is using a new binary protocol, which is it's just different. It is not compatible with how HTTP1 is represented. And what this means is that when the server starts receiving the first bytes of the HTTP requests, the server needs to make a decision right away about how it is going to process or how it is going to interpret those bytes of the message. And it cannot do both. It has to do either one or the other. And I think even ASP.NET, so even ASP.NET prints a warning. What this warning basically says is that Kestrel is configured to support both HTTP1 and HTTP2, but on the unencrypted HTTP endpoint, that's just not possible. So this is why if we are trying to use the unencrypted HTTP endpoint, then and Kestrel is configured to support both of the protocols, then ASP.NET just gives up and it says that it will default to HTTP1. And also what the browser does is it is going to send HTTP1 because it doesn't know what the server is going to support. So this is the reason why if we use this configuration and we use unencrypted HTTP, then this request is going to work, but gRPC is not going to work. And then the other question was, why is this then working if we are using HTTPS? So if I'm using HTTPS here, then it still works. And if I change this back to HTTPS, then this is also working. The reason for that is that HTTPS includes a handshake operation before the actual HTTP request begins. And the main purpose of that handshake is to set up the secure encrypted tunnel over which the HTTPS communication is going to happen. But when they introduced HTTP2, they figured that, well, if we have that handshake process there already, besides using it for setting up the secure tunnel, it could be also used to negotiate what kind of protocol the client and the server is going to use. And that is what happens. So in this case, if you are using HTTPS, then the browser and Kestrel in front of ASP.NET, as part of the TLS handshake, they are going to negotiate what protocol they want to use. And in this case, I think in this case, they are actually going to use HTTP2 because both the browser and ASP.NET supports it. But this is how both types of the communication can work if we are using HTTPS. This is called ALPN, which stands for Application Layer Protocol Negotiation. And I think the takeaway from this is that if you are already using HTTPS on the level of your ASP.NET application, then typically things just work because then the client and the server will negotiate, and if they figure it out. On the other hand, if you're using unencrypted HTTP, which is a genuine scenario that can happen, for example, if you have your ASP.NET application in a container, let's say in Kubernetes, and you have a reverse proxy in front of it, like Nginx, which takes care of the TLS termination, then it can be a real scenario that ASP.NET itself is going to listen on unencrypted HTTP, and only the reverse proxy in front of it is going to use HTTPS. In that case, you need to be very aware of this problem. And if you want to support both HTTP2 and HTTP1 endpoints in the same service over unencrypted HTTP, then what you can do is use two separate ports. And I'm not going to show this with a demo because it would take a bit more time, but I'm just going to show what it looks like to do that configuration. I don't think you can do that in the app settings.json, but you can do it in C#. So with this piece of code, we are configuring Kestrel to use HTTP1 on port 5000 and use HTTP2 on port 5001. And this way I can access gRPC services on this port, and I can access REST endpoints on this port, and both can use unencrypted HTTP. So that's the way you can make this work. And we have a summary of this here on the slide as well. And I have a diagram here which also illustrates this. So in this diagram, what you see is a server which is using unencrypted HTTP. And if you want to support both protocols, then you need two different ports. And this approach is called prior knowledge, which means that the client has prior knowledge about the fact that the server is supporting HTTP2. So when it is sending requests to that port, it can send HTTP2 on it. And then the second setup is if the server is using HTTPS. In that case, you don't need to separate ports. The setup is simpler. You can support both HTTP1 and HTTP2 on the same port because during the handshake, the client and the server is going to negotiate. And the last thing that I wanted to mention is how HTTP requests and gRPC requests relate to each other. This is also something that can be confusing or surprising at first. One thing is that gRPC is not really utilizing the concepts of HTTP. So a gRPC response on the HTTP level is always using the 200 OK status code, even if the gRPC request failed. That information that the gRPC request failed is going to come back to the client in the binary response. And on the client side, you can catch it as an exception and then handle it accordingly. But it's not going to show up on the HTTP level as a 500 or any other status code. So if you, for example, have logging or monitoring or alerting for your services responding with, let's say, 500 status codes, for gRPC, that is not going to work because even if all of your requests are failing, the HTTP status code is still going to be 200 OK. And another similar problem can be is when you have a long-lived gRPC streaming connection and you are transferring many small messages, that might still count as just one single HTTP request. So if you are counting HTTP requests and visualizing request rates or error rates, that can also lead to misleading results or statistics. And these various RPC patterns can be handled with interceptors separately, so you can make a conscious decision on how to handle these in terms of logging, metric collection, alerting. This is all that I wanted to share with you. I hope that it was useful. And on the last slide, I've collected a couple of resources that can be useful if you want to look into gRPC in more detail. Thank you all for listening.
Thank you, Mark. We already have 2 questions, so let's start the Q&A section. In what cases gRPC has better and worse performance than HTTP calls?
I think that is hard to say. You will only know if you actually do a benchmark or a comparison. The things that will be better with gRPC is the time to do the serialization, because the binary serialization and deserialization is typically faster than JSON. And the other thing is that the size of your messages over the network are going to be smaller. Although if you use JSON with REST, then the actual bytes over the network typically get compressed. So there might not be that big of a difference in practice. So I think the only surefire way to know is to benchmark. From my perspective, I think that the performance benefits actually are not the main benefits of gRPC. For me, the static contracts and the code generation and developer experience that you get out of that is even more important. But if there is a service that is very heavily used and has a high request rate, then it can be very beneficial. But you only know if you do a benchmark.
Okay, thank you so much. And here's the other question, the next one from Károly. Doesn't using HTTP to hold back truly good performance in case of gRPC? I guess there are more efficient TCP-based communication protocols than HTTP.
Yeah, I mean, definitely. I think what you need to balance there is um, the easiness of use and the convenience and the developer experience. So gRPC improves on the performance of REST services and still provides a pretty easy to use tooling and developer experience. So your code and your server implementation and client implementation does not get overly complicated. But if you wanted to go even lower level and implement a custom protocol on top of TCP directly, which would be even more performant, that would be a lot of development effort and it would be a lot more complicated. I'm sure that there are cases where that is really worth it, but I would say that that is probably a pretty specialized application, and I don't think that too many companies need that level of optimization. But yeah, definitely, if you would go down to the TCP level, you would probably be able to implement something even more performant, but it would take a lot of development.
Okay, great. And thank you so much. And there's another question from Gabor. The proto file has type members with the default values, but all the values are numbers, even if the member is string typed. Is it right? It's a bit confusing for me, says Gabor. What is the point of the default values?
Okay, so this is a really good question, and indeed, I did not mention this explicitly. So you see here in the Protobuf syntax that there is an equal sign, and then there is a number here, and this looks like as what the default value would look like in something like C#. But in Protobuf, this is not a default value, but it is the index of the field. In Protobuf, every field must have an index, and it has to be a different index. And this is what the Protobuf serializer and deserializer is using to serialize. The way Protobuf achieves a pretty small data size in the serialized binary is that it is not serializing the names of the fields as metadata. So in the actual binary stream or byte array, these names, they don't show up. But what Protobuf does is it serializes the fields in the order of these indexes. And then what the client is going to do is it is going to, when it deserializes, it expects the fields or the values in the binary stream to be in this order. And if you just start with a new application, then you don't really have to worry about this. You will just use incrementing values. The time when this becomes really relevant is when you want to do a breaking change. For example, you want to delete a field. Because if you deleted, let's say, this ID field, and then you introduced another field of a different type with the same index, that would break a client, because a client would expect an integer to be there, but then you might put a string in the same place. So one thing that is important is if you deprecate or remove a field from a model, then this number should never be reused so that you don't break existing clients.
Okay, thank you. We got it. And we have another question. What to do in case we would like to change the order of the properties?
I mean, if you would just like to change it in the file, you are free to reorder them as long as the indexes stay the same. If you would want to actually change the indexes, I don't really know about the genuine use case to do that, because what this affects is only the order of the fields in the binary stream itself. And that's not really something that you typically look at manually. And I think reordering the actual indexes is not something that you typically do, because once you change this order, for example, I would replace this 1 with a 3, then all of the clients would be broken because they would deserialize it in the other direction. So email would go into name and name would go into email on the client side. But if it's just about reordering the lines in the file because you want to make the code more readable, you are free to do that as long as the same index stays with the same field. And in general, when it comes to doing changes in Protobuf, you have to be pretty careful, more careful than when you're using JSON, because it's a binary format. So if something goes wrong, then the client can be broken immediately. And it's not just going to cause, let's say, one field being empty, but the complete message can be garbled. So before you do a change, you really have to think through how that is going to affect existing clients. And typically adding a new field to the end of a message is safe, but removing or changing fields, that is something that can be risky. And sometimes it might be better to introduce a new version of the type and the new RPC, and then get your clients to migrate to the new one, and only then remove all of the old models. So yeah, that is something that we have to be really aware of and careful with.